topic is going to be solving quadratic equation by completing the square. So what is the standard form of a quadratic equation? How do you recognize a quadratic equation? General form of a quadratic equation is this, okay? This is a general form of a quadratic equation. Now, completing the square, when they talk about completing the square, what do they mean by that? They're talking about the square of a binomial. For instance, if I have x plus 2 is squared, okay? How do you solve that? X plus 2 squared. Well, it's going to be x plus 2 times x plus 2, right? And then we apply the FOIL method. X times x is going to be x squared. X times 2, 2x. 2 times x, 2x again. And then 2 times 2 is 4. Now here, we have twice this, right? So we multiply 2 times 2, it's 4. So we're going to have x squared plus 4x plus 4. Okay? Now, if instead of 2 we have 3, what's going to happen? Well, we're going to have x plus 3 is squared. It's going to be what? Again, we do the same thing. Then it's going to be 3 plus 3, and then 3 times 3 is 9. So we're going to have x squared plus 6x plus 9. Okay, so you see, for x plus 2 squared, this is what we have for x plus 3. And then let's see, x plus 4, what's going to be? It's going to be x squared plus what? 8. 8x plus 16. If I have x plus 5, it's going to be x squared plus 10x plus 25. I think now we can generalize. If I have any binomial, and then I say b instead of a letter, right? I'm generalizing here. It can be any number. So what's going to be the formula? It's going to be x squared plus what? Just look at this pattern. Huh? 2b. Very good. 2bx plus b squared. So it's good to have this in mind. So if I give you, let's say, x squared plus 12x plus 36, can you tell me what is the binomial that I'm squaring here? X plus 6. Okay? Now, let's say, now I have here, instead of 36, I have 35. And this is a quadratic equation, and I'm asking you to solve this. Let's say I have 35 here. Is this a complete square? No. What is missing here? 1 unit, right? Just 1, right? If I could add 1 on this side of the equation, I would have 36. And I would be able to complete the square. Isn't that true? But to do that kind of magic, we need to follow the rules, right? What is the rule? If I add 1 on this side, what is there I need to do on the other side? Add 1. And then that's what we're going to do, okay? X plus 12 plus 1 plus 35 is 36. But then 0 plus 1 is 1. Okay? Is this okay so far? So now I can write this in form of a binomial, right? This is 6, okay? Because 36 squared is 6 squared is 36, and 2 times 6 is 12, equals to 1. Well, why is this a good way to solve a quadratic equation? Look, if I square on both sides now, okay, I have reduced the degree from 2 to 1. And that makes life much easier, right? So if I square root on both sides, I'm going to have here x plus 6 equals plus or minus square root of 1. Square root of 1 is 1. So now I'm going to have x plus 6 equals to plus or minus 1. X equals minus 6 plus or minus 1. So that means there are two solutions here. One when I use plus and the other one when I use minus. So one is x minus 5 and the other one is x minus 7. Okay? So is this a solution for here? Well, let's check, okay? If I add, how can I factor this here? Can I factor, is this factorable? No, this is not factorable. Is it this factorable? No, it's not. Can I find two numbers that when I add is going to be 12, and when I subtract is going to be, when I multiply is going to be 35? Can I do that? No. Yes or no? Huh? No?
Yes.
Yes. So how do I factor that? It's going to be what? X plus what? 7, and then x plus 5, right? So I'm factoring this. I'm trying to solve this by factoring now. So 7 plus 5 is 12. 7 plus 5 is 35. Good. So what is the solution here? Well, this is a product of two numbers that is equal to 0. This is equal to 0, or this is equal to 0. In that case, I find the same solution that I found here. Do you see that? So one method is called completing the square. We just follow these steps here. And then the other one is by factoring that we solve that. The other method that we have to solve quadratic equations is by using the quadratic formula. The quadratic formula is x plus negative b plus or minus b squared minus 4ac 2a. So let's use that formula now and see what's going to happen. What is the value of b here? 12. So it's going to be negative 12. And by the way, the quadratic formula works for any quadratic equation. It so happens that this one here is a factorable quadratic equation, right? So we could factor and solve it. We also use the completing the square strategy, right? Method to solve it. And now we're using the quadratic formula, okay? So 12 squared is 144 minus 4 times a. What is the value of a? 1. What is the value of c? 35. 2. So 4 times 35 is going to be 140, right? 140. 144 minus 140 is 4, so now I can write negative 12 plus or minus square root of 4. Square root of 4 is 2 divided by 2. So here we have two solutions again, plus or minus. 12 plus 2 is 14, divided by 2 is 7. So we've got 7. And 12 minus 2 is 10, divided by 2 is 5. You've got 5. Okay? 3 methods, the same answer. Okay? How's that? Is that good? Okay. So let's do now something different. Let's generalize. Maybe I can write, I can leave everything here and I can, let's generalize the quadratic equation. Let's say I have ax squared plus bx plus c equal to 0. And I want to solve by completing the square, okay? I want to solve this here. This is a general form. A could be any number, B any number, and C any number. And I want to solve this by completing the square. What is the first thing that I need to do here by completing the square? Remember, when we have the square of a binomial, we always have what kind of coefficient here? What is the coefficient here? 1. Do we have a coefficient 1 here? Well, A could be 1, but because A could be any number, so could be 2, 3, right? So how can we ensure that we always have 1 here? Here. What should I do to this equation to make sure I always have 1 there? Oh, fantastic. Divide everything by A. Let's do that. So now I'm going to have x squared plus b over a plus c over a. 0 over a is 0. Okay? All right? So now I'm in this situation here. What is that I did? How can I figure out that number here, 6? From here, how can I figure out what is the strategy that I do to figure out this number? Look, the general form is 2b. How can I figure out the value of b? If I want to find the value of b here, right? What should I do? What's the relationship between 12 and 6? Between 4 and 2, between 6 and 3, between 8 and 4, 10 and 5. If I have 10, how can I calculate 5? What should I do? What is the...
Double.
Huh?
Double?
Double? If I double 8, I'm going to have 16.
I mean, it's the half.
Divide, right? Divided by 2. So this b here, this number that goes here, is this thing here divided by 2. So this divided by 2 is going to be what? So it's going to be b 2a, right? This is my b line. This is like, let's call this b line, okay? This is my b line. My b line is this divided by 2, okay? Now, in order to complete the square, I have to have here the square of b, right? If this is b, what is the square? What is the square? What is the square of this b line? It's going to be b squared 4a squared. Is that okay? Are you guys following me, or it's too big of a, it's a big gap? I'm just trying to solve this equation here, okay, by completing the square. And I'm looking at this value here, the same way we look here at 12. How can I complete the square? Well, I have to divide by 2 in order to figure out the value of b, so I can figure out this b squared. I know b squared has to be 36 because b is 6, all right? In this case, this term was not 36, so we had to adjust it, okay? Now, if I say this is a number, just think this is a number. I just divide that number by 2, right? That's what I did. And then I squared that number so I can figure out what is the number there, all right? So and again, the same way I add 1 here and here, because, you know, that's what I needed, right? So I'm going to add this quantity on both sides, just to make sure I can complete the square, okay? So by adding that on both sides, what is that I'm going to have? Let's see. I'm going to have something like this. So x squared plus over ax plus this guy, because I know this is what I need to complete the square, right? And then plus c over a equals b squared 4a squared, right? I add this quantity here on both sides, okay? That is the b squared. And this is the number that I had, right? I had here 35, right? I could add, instead of 1, I could add 36 and 36 on both sides. So that's what I'm doing here. So now I know that the square is going to be what? X plus, what's going to be here? What is the value of b? The value of b is this here, right? Is b over 2a squared. Right? And if I move this guy to the other side, it's going to be b squared 4a squared minus c over a. All right? Is this good so far? Is this okay? Now, this is subtraction between two fractions, right? I need to have a common denominator here. How can I figure out the common denominator? What is the common denominator here? 4a squared and a. What would be the common denominator? A.
4a.
4a or 4a what? If I have, let's say, 1 over 8 and 1/4, what is the common denominator? 8, right? So the common denominator here is 4a squared. I need to have 4a squared here. In order to have 4a squared here, what do I need to do? I need to multiply by what? What is 4a top and bottom, right? 4a top and bottom. So I need to do b squared 4a squared minus 4ac, right? 4ac, right? Because I multiply 4a here, so I have 4a squared, and on the top I multiply by 4a, so now I have 4ac. Okay? So let's now write this beauty here, right here. So I have now x squared plus, not x squared, just x plus b2a squared equals this guy, right? b squared minus 4ac divided by 4a squared. All right? Now, to find the value of x, what do I need to do? What have I done here to find the value of x? What have I done here? From here to here. What was the operation that I did here?
Looks like you removed 1x.
Yes. But I had square here, now I don't. What to do? The square root, right? Square root here, square root here. If I do the square root here of square, I have x plus 6, and here I have that. So let's do that. If I have the square root here, this is going to disappear, so I just have x, a, to a. Now the square root of this whole thing here, b squared minus 4ac plus or minus 4a squared. The square root of 4a squared is equal to what? The square root of 4 is 2. Square root of a squared is 8, right? So I can do that here. So I'm going to have x. I can move this guy to the other side. It's going to be negative b 2a plus or minus square root of b minus 4ac divided by 2a. I can combine these two denominators here, so I'm going to have negative b 2a plus or minus square root of b squared minus 2ac. Is this here something that looks familiar? This is the quadratic formula, right? So what I just showed you is how to come up with this formula from the general format of the quadratic equation, okay? Just by using the strategy of the method of completing the square, okay? So completing the square works for any quadratic equation. And so this formula here, we can use this formula to solve any quadratic equation. Now, when you are able to factor, of course you want to do this by factoring. It's much easier and much faster. Is that okay?